Okay, so we got that 6. Then the first 2 medium pizzas cost $6. So if I bought 2, the first 2 were $6, so the second one would be $12. So 1 for 6, 2 for 12. So then we need to look at the next one. How do I get for 3 pizzas how much it would cost? Well, the first 2 pizzas were $6 and all additional pizzas cost $4. So instead of doing 3 times 6, I'm going to do 2 times 6 was 12 plus one group of 4. So that's only $16, whereas on the other one, 3 pizzas would have cost $18. Then for 4 pizzas, it's just one additional $4 cost, so that would be $20. So this is my table here for this situation. So we can check the constant of proportionality. We can check what 6 over 1 gets us, 2 over 12, 12 over 2, 16 over 3, and 20 over 4. So if I pull out my handy dandy calculator, excuse me. Okay, so if we look here, we have our calculator out. So we're going to talk about the proportional relationship. So we're going to compare y to x and get it down to its unit rate to see if they're the same for each one. So I'm going to do the first one. The first y value is 6 over 1. Well, that means this is already the unit rate. This is already for 1 pizza. So 6 over 1 is just equal to 6. So that's my constant here of proportionality. So to get from 6 to 1, I could just do, from 1 to 6, I could just do times 6. Well, let's go down to for 3 pizzas and check that constant of proportionality. Remember, if they're the same, that means they're equivalent rates. That means they can be really proportional. So if I did 16 over 3, that's my y value over my x value. And I can type that in my calculator. We want to get that down to for 1 pizza. So we would divide by 3 and divide by 3. So 16, 16 divided by 3. So 16 divided by 3 equals 5.3 repeating. Well, 5.3 repeating over 1 means it's just 5.3 repeating dollars per pizza. So that constant of proportionality is not equivalent to this, so that means that this cannot be proportional. So if we look at this information here, 6 over 1 was 6, but 16 over 3 was 5. I said 5.6. I think it's 5.3 repeating. And then 20 over 4, if we went on and checked this one, this y over this x would have been 5. So these aren't the same. They don't have the same constant of proportionality. So these aren't equivalent. And if we look at the process, we really can't even have an equation here. We have 1 times 6 and then 2 times 6, but then we start doing plus 1 times 4. This is not a proportional relationship. So let's look at the graphs really quick, and we're not going to get to do all of this right now, but I do want to point out one thing. I can look at this graph and check by the graph if this is proportional because it is a straight line, and if we look here, it does go through 0, 0. So when I look at my proportionality, 2 over 3 would be my y over my x. So I think that this is proportional because it's a straight line. It goes through the origin. If I talked about my constant of proportionality, I would do y over x equals, well, my next y over my next x would be 4 over 6 equals 6 over 9 equals 8 over 12. So if you look at these, you should be able to tell that these are equivalent, but if you couldn't, you could just break them down to unit rate. But these are because 2 times 2 is 4, 3 times 2 is 6. 2 times 3 is 6, 3 times 3 is 9. So this is a proportional relationship. Quickly, if we look at this one, we can tell that this is not proportional, and here's why. Though it is a straight line, the line does not cross through 0, 0. The origin, it crosses through 0, 4. So this is not proportional because we don't start at the origin. Then if we look at the constant of proportionality, we have 6 over 1 equal to 8 over 2. If I simplified 8 over 2 over here, so if I change this color and I said, what is 8 over 2 equal to over 1? It should be 6 over 1 if it were proportional.